Good morning, everybody. We're allowing everybody a bit of time to get in. So we'll get started in a couple of minutes. Nice to see all of you already. Thanks for joining on time. Welcome, everybody. Still see people joining. So for people that just joined, welcome to our first session of today. We'll be starting in a couple of minutes. And okay, Serena is already faster than I am, Roman. So we will be recording this session, and it is being recorded already. So be careful what you say. Well, I need to be careful what I say potentially, but the recording will be distributed afterwards. All right, it's 11:01, at least at my clock, so we can get started. Yet again, welcome everybody. For everybody who is joined or will be joining slightly later, this meeting will be recorded as well. So, well, you can have the replay of the very unuseful first minute. So, welcome to our very first session of the GitLab Demo Day series, Level Up Your DevOps. As in this first session, we'll be covering the basics or concept of the GitLab CI/CD. Might be hinting to a couple of more advanced topics already, which will be the next session, I believe, hosted on Thursday, the 17th, if my memory serves well. As usual, or for those of you who are attending for the first time at a GitLab webinar, if you have any questions, feel free to put them in the Q&A section or in chat. Q&A section is preferred because then it will be easier for us to collect the questions and to make sure that we don't miss any questions. We have my team members, Vlad and Serena, that will help out on any questions already. If not, we will have a session, Q&A section after the session as well. So My name is Christoph Goossens. I'll be your designated presenter for today. So apologies, you will be stuck with me for the next half an hour or so, hour or so. It's nice to see some familiar faces already, but also a lot of new faces. So welcome and nice to meet all of you. For today's agenda, or for today's menu, we'll be covering a couple of basics of CI/CD, starting with how GitLab actually runs, or the CI/CD portion of GitLab, covering topics like GitLab Flow, the architecture of CI/CD, and how to work with the runners. Next, we'll cover the topic, the pipeline as your lifeline, or in other words, how to get started with pipelines. And in the end, we should have time left for some questions and potentially some answers as well. So let's dig into it. So Git in general allows a wide variety of branching strategies and workflows. But because of this, many of the organization end up with a very complex workflow that is not clearly defined or not integrated with issue tracking systems. Therefore, we are proposing GitLab Flow as a clearly defined set of best practices. And it combines feature-driven development and feature branches with issue tracking. The GitLab Flow is a clearly defined set of best practices, like a simplified branching strategy that allow you where all the features and fixes first go to the main branch. It allows you to have production or stable branches, and bug fixes, hot fixes, patches are being cherry-picked from the master. We are recommending for DevOps teams to follow the GitLab Flow process while using GitLab's capabilities with a concurrent development lifecycle. The GitLab application is based around a feature branch workflow, and the merge requests can be thought of as one of the core components of our product. The gray line at the bottom that you see here on the screen is the main branch of the master branch. And you'll notice another gray line that will break off the main branch and eventually tie back into it. This is what which is known as the feature branch. The feature branch represents the source code pattern where a developer opens a branch, begins to work on a new feature, and is then going to integrate the work back into the main branch. Typically, in this GitLab Flow, we're starting with a discrete unit of work, which by creating an issue, think of it as a ticket, a defect, a user story, whatever you like, and we can assign this issue to a team member. From the issue, we spawn a feature branch, which is in essence a parallel line of development. Developers move to the branch to interact with the request, and GitLab provides updates and notification on the state of the issue automatically. If you work with the feature branch for more than a few hours, it's best practice to share your results with your immediate team. It may not be ready to be merged, but the feedback is always welcome. Because the faster your feedback, the easier it is to adopt and to iterate on it. Your team can make comments on the merge request in general on specific lines, and the merge request is essentially serving as a code review tool, and no separate tool for this should be needed. When you are comfortable with your work, the comments made, you can assign to somebody else who knows the most about the code base, or somebody who has permission to merge back into the main branch. And we have code review and conflict resolution built into the platform for merge conflicts. The commit starts off the automated continuous integration pipeline that runs and goes through all the steps that you see on the right side of the slide. And the advantage here is that the developers have visibility into what's going into the cycle as well. But perhaps we can work out a quick example on how it could be implemented. Again, it's just an example, so it's not something that needs to follow this process, but it's an example on how you can do it. First, we're going to create and discuss a new issue. And in order to do that, a team member is going to create an issue inside GitLab for a new feature that we will be implementing. Then the team member applies a label discussion to the issue, and various team members can discuss the new feature by entering comments to the issue. The issue will now appear on the project's issue board in the discussion list. And other labels for this project include backend, front-end, working on, staging, ready, and production. It's essentially a way of creating your own workflow. In the code creation phase, the backend team starts working on an issue and changes the label to backend. This will reflect the status of the issue. So everybody knows that the backend team is working on it. The assigned developer starts writing the code and assigns the issue to himself or themselves and changes the label into working on. Next, in the commit and merge request phase, the developer creates commits and pushes the commits back into the feature branch. From there, we're creating a merge request, and the backend team moves. Finally, the backend team removes the backend and working on labels and adds the label front end. Then we're ready to start deploying to staging. In order to do that, a front-end developer starts working on the issue, adding the label working on, and assigning the issue to themselves. After the code review is completed, the code is being deployed to the staging environment, and the team removes the labels and adds the staging label. After successful implementation in staging, the team removes the staging label and adds the label ready. In the ready phase, other teams prepare the technical documentation and the marketing campaigns, for instance, each adding their own labels, docs, and marketing. As each team is done, they remove their own labels, and the last team done removes the ready label and adds the production label. So we're now ready to deploy to production. And in this last step, the release team member merges the merge request, and the feature is automatically deployed into the production environment. The release team member continues to close the issue, and we're done. We have created from the issue, we have deployed all the way into production. And again, it's only an example, but I hope it gives an idea on how you could implement it. So, what is CICD? So CICD stands for Continuous Integration and Continuous Delivery. And it can be thought of as a culture or a methodology, a set of best practice of operating principles that enable application development teams to deliver code changes more frequently and efficiently. The implementation is also known as the CICD pipeline. Starting with continuous integration, it's a development practice where developers integrate code into a shared repository frequently and preferably several times a day. Each integration can then be verified automatically by an automated pipeline of scripts that build and automate and run automated tests before merging them into the main branch. While automated testing is not strictly part of CI, it is typically implied. Next is continuous delivery. Continuous delivery is the practice of keeping your code base deployable at any given point. Beyond making sure that your application passes automated tests, it has to have all the configuration necessary to push into production. Many teams then do push changes that pass automated tests into a test or production environment immediately to ensure a fast development loop. Continuous deployment is closely related to continuous integration, but pushes the changes to production automatically. It refers to keeping your application deployable at any given point or even automatically releasing to an environment if the latest version passes all the automated tests. If you do all of this, it leads to a couple of things. It leads to low risk releases that can be performed anytime on demand, which in turn provides a faster time to market. It's usual for development cycles to take weeks or even months. And when teams work together to automate the build and deployment, environment provisioning, regression testing processes, developers can incorporate integration and regression testing into the daily workflow and completely remove the phases. We can also avoid the large amounts of rework that plague the phased approach, which turns into higher quality as well. So when developers have automated tools that discover regressions within minutes, teams are free to focus their effort on user research and higher level testing activities such as exploratory testing, usability testing, and performance and security testing. By building a deployment pipeline, these activities can be performed on a continuous basis throughout the delivery process, ensuring that quality is built into the products and services from the beginning. It will lower the costs. So by investing in build, test, and deployment and environment automation, we substantially reduce the cost of making the delivery delivering incremental changes to software by eliminating many of the fixed costs associated with the release process. And better products. We can get feedback from our users throughout the delivery lifecycle based on the working software. And last but not least, happier teams. Continuous delivery makes releases less painful and reduces the team burnout. Furthermore, when we release more frequently, software delivery teams can engage more actively with users, learn which ideas work and which don't, and see firsthand the outcome of the work that they have done. So GitLab Basic CI/CD workflow. Consider the following example on how GitLab CI/CD fits in a common development workflow. Assume that you have discussed the code implementation in an issue and worked locally on your proposed changes. After you push your commits into the feature branch in a remote repository in GitLab, the CI/CD pipeline set for your project is being triggered. By doing so, GitLab CI/CD will run the automated scripts sequentially or in parallel to build and test your application, preview the changes per merge request with the review apps, as you would see in your local host. And after you're happy with your implementation, you can get your code reviewed and approved, merge the feature branch into the default branch, and GitLab CI/CD will then deploy your changes automatically to a production environment or to the next environment first. Finally, you and your team can easily roll it back if something goes wrong. So that's also very important. So GitLab CI/CD is capable of doing a lot of more, but this workflow exemplifies GitLab's ability to track the entire process without the need for an external tool to deliver your software. And most usefully, you can visualize all the steps throughout the GitLab UI. If we take a deeper look into the basic workflow, we can see the features available in GitLab at each stage of the DevOps lifecycle. From the image to the left, you can see some of the features available in GitLab according to each stage, which is verify, package, and release stages in this case. The verify stage will automatically build and test your application with continuous integration and analyzes your source code quality with a feature called GitLab Code Quality. It will determine the browser and server performance that impacts code changes using browser performance and server load performance testing, both of which are pipeline features that are built into GitLab. In the package phase, we will store the Docker images into the Docker container registry that is built in, and store packages with GitLab package registry. And last but not least, in the release phase, we're doing the continuous deployment. We're automatically going to deploy your application into the production environment, and GitLab is supporting the deployment of static websites with GitLab pages as well. We ship features to only a portion of your pods and let a percentage of your user base to visit the temporary deployed feature by using the canary deployment. And then there's still some other features like deploying your feature behind feature flags, adding release notes to any Git tag with GitLab releases, view the current health and status of each CI environment running on Kubernetes with deploy boards, deploy your application to production environment in Kubernetes cluster with auto deploy, and many more. You have we'll share a link as a follow-up to see all the CI/CD features that are included. And of course, make sure to follow the next sessions as well. So why are we using CI/CD essentially? And with GitLab's out-of-the-box CI/CD, you can spend less time maintaining and more time creating. And why use CI/CD? Well, CI detects errors quickly, which means that you can fix errors while they're fresh in your mind. And I don't know about you, but well, for me, it's easier to fix something that I did today than something that I created, well, a couple of months ago. CD delivers value quickly and more often. So you can get faster feedback on what your end users care about. Are we doing it in the right, going in the right direction? And do we need to pivot away from the direction that we have at the moment? Sorry. CD reduces the integration problems. So smaller problems are easier to digest, and it ensures the problems don't compound and build to a larger problem. CD also ensures every change is releasable, which lowers the risk of each release and allows releases to be boring. And at GitLab, we like boring solutions because it's not always the bad solution that are boring. CI allows teams to develop faster as well, which gives you more confidence among the developers, which allow for less bottlenecks. In general, there are too many integration points that are needed. So connecting CI/CD to all the different tools in a DevOps tool chain is confusing and keeps adding more steps and more points of failure to the process. Can also lead to brittle tools because we're spending more and more time maintaining and update these tools than actually creating features, which will slow the modernization because we want to leverage microservices and cloud native development, but we're spending too much time putting out fires. And that's why it's important to have a tool like GitLab, which incorporates all of these features in a single tool. Now, enough of the, well, let's say boring stuff. Let's see how GitLab actually does it and how we run everything. In order to get started with GitLab CI/CD, you mainly need two things. First is the .gitlab CI YAML file, which is essentially the pipeline definition file. It's going to specify the stages, jobs, and actions that you want to perform, in what order you want to perform them. And essentially, you can think of the YAML file as the brains. And next to the brains, you have the body. And GitLab Runner can be considered the body because it's going to execute everything that we defined in our YAML file. So you have to have at least one GitLab Runner that can pick up all the jobs that are requested by the GitLab CI YAML file. A GitLab Runner is a lightweight, highly scalable agent that picks up a CI job through the coordinator API of GitLab CI/CD. It runs the jobs and then sends the results back into GitLab. The runner can be installed on any platform because it's on any platform where you can build Go binaries, essentially, including things like, well, you see the list there: Linux, Mac, Windows, FreeBSD, bare metal, workstation, Docker, even mainframe has now been added. The GitLab Runner can test any programming language, such as the examples here: .NET, Java, Python, C, and others. And these are typically created by, well, either your administrator or one of the team members and made visible in this GitLab UI for certain tasks and jobs. In the UI, there are three main types of runners based on who you have to address. Shared runners are available to all groups and projects in the GitLab instance. Specific runners are associated with specific projects or groups and with specific projects, and typically specific runners are used for one project at a time. And then you have group runners, which are specific runners but dedicated for a specific group. So are available, and those are available to all the projects and subgroups in a group. Let's go into it slightly deeper. So a shared runner. So shared runners are available to every project in the GitLab instance. Using shared runners when you have multiple jobs with similar, you can use shared runners when you have multiple jobs with similar requirements. Rather than having multiple runners idling for many projects, you can have a few runners that can handle multiple projects. Shared runners process jobs using a fair usage queue. This queue prevents projects from creating hundreds of jobs and using all of the shared runners resources. The fair usage queue algorithm assigns jobs based on the projects that have the fewest number of jobs already running on shared runners. On the other side, we have the specific runners, and specific runners are used when you want to use runners for specific projects. For example, when you have jobs with specific requirements, like the deployed job that requires credentials, or projects that require a specific operating system type, like when you want to build a Mac application or an iOS application, you probably need a Mac for that. And so you'll need to have a runner that is capable of running those kind of jobs as well. And you can set up the specific runner to be used by multiple projects as well, but specific runners must be enabled for each project explicitly. Of course, you can use the API in order to do that as well. Next, we have a difference between tagged and untagged runners. Tags can be used as part of our definition to select a runner from a pooling algorithm. A tagged runner will only be selected to run jobs that are tagged with a specific tag. Runners should be set up to run all of the different types of jobs that it may encounter on the project it's shared over. So this would be problematic for large amounts of projects if it weren't for tags. GitLab CI tags are not the same as Git tags. So GitLab CI tags are associated with runners, and Git tags are associated with the commits. By tagging a runner for the type of job it can handle, we make sure that shared runners will only run the jobs that are equipped to run. So in this case, for instance, if you want to run an MS build job, you need to have a Windows machine, for instance. So you can potentially tag your Windows runner with the tag Windows. And as you can see on the left side of the screen over here in the tag section, you will assign it to Windows runner. And so we will make sure that it's a runner that has the same tag that will pick up the job. Sometimes we have to be careful with, well, we always have to be careful with sensitive information and prevent runners from revealing this sensitive information. You can protect these runners so they don't reveal this information. And when a runner is protected, the runner picks up the jobs created on the protected branch or protected tags only. And it ignores the other jobs. GitLab recommends this protecting the runner if it contains things like deploy keys or other sensitive capabilities. To protect the runner, you can navigate to the project settings and check the protected option for the runner and click Save Changes. Next, once we selected the right runner, whether it's protected or not, we have a couple of executors that will pick up that will run the build essentially. So GitLab Runner implements a number of executors that can be used to run your builds in different scenarios. So the executor provides the dependencies for your build need to be installed in the environment required for the GitLab Runner. So the GitLab Runner can be configured with multiple execution environments, depending on how we want our runner to carry out instructions. Executors allow you to specify your own execution environment. When the GitLab Runner does not provide an executor, for example, for LXC containers, you're able to provide your own executables to GitLab Runner to provision and clean up any environment you want to use. The two most common executors are Shell and Docker. Shell is the most basic. It means that whatever the runner has available to its environment, it is essentially what it can execute. As an example, if we install our runner process on a T2 micro instance in AWS, on a CentOS instance, we would need to yum install all the prerequisites required by our jobs and set all those environment variables that would be necessary to compile them and build our project ahead of time. We would need to either install and configure those ahead of time, which will may take a lot of time. For Docker machine and for Docker, that's not necessary because you can specify the image that you want to use, and the environment will already be prepared as part of that Docker image. And as usual, we have more information available online. Now let's start building our first pipeline. The pipeline itself is the fundamental building block of continuous integration, delivery, and deployment. A pipeline will be created when a new push is made to the GitLab repository, and this pipeline would immediately run when there is an idle GitLab runner or be put in a queue if all available runners are busy with something. Continuous integration is built in and works to integrate code provided by your team in a shared repository. Developers share the new code in a merge request, and the request triggers the pipeline to build, test, and validate the new code prior to merging changes with your repository. Continuous delivery ensures the delivery of CI validated code to your application via structured deployment pipelines. Together, CI and CD will help your team deliver fast results for your customers and stakeholders. So GitLab CI/CD performs the following tasks automatically. First, it will build your application. Then it will run unit and integration tests to check whether your code is valid. We'll look at the live preview of your development branch with review apps before merged into the stable release. And finally deploys to multiple environments like staging and production, and support advanced features such as canary deployments. So the first pipeline architecture, or basic pipeline architecture, is as follows. So at the top level, you will see the different stages that are being defined. And below that, for each stage, you have the one or multiple jobs that belong to that stage. By default, all stages in one, all jobs in one stage need to be completed before moving towards the next stage as well. Within the stage itself, by default, all the different jobs are running in parallel. Even with basic pipelines, we do have a couple of options that can be useful already. So in this case, you'll see that there's an exclamation mark at test B, and this means because this job was configured to be allowed to fail by setting the allow failure to true. Since a couple of releases, you can be even more granular to that and specify which exit codes you are expecting, and then allow to fail on those exit codes, and all the other exit codes will still fail your job. The other example over here is a manual job. So when the job has a setting called when is manual, then it will wait until somebody will click the play button before it actually gets executed. Or if you can also trigger this by using an API call from an outside tool, for instance. So this is an example of a pipeline graph that shows what the CI/CD build looks like. It lets you it lets you see how a set of one or more jobs are executed in the stages that you have defined in the YAML file. So first of all, the stages are a collection of jobs to be run in parallel, and there are some default stages like build, test, and deploy. In this example, the CI file has 4 pipeline stages that are defined, which are the build, test, staging, and production. The stages in the pipeline run in serial to each other. Then you have the jobs, and the jobs are the scripts that need to be performed. For example, in these examples, the test 1, test 2, and the likes. As mentioned, the jobs in each stage are executed in parallel, and if one job in the stage fails, the next stage is not executed, usually. Then you have some environments. Environments are where we deploy to. For example, build, test, staging, production, and the likes. These can be specified in the jobs within the CI YAML file as well. And last, what we also can see here are the icons and the buttons in the graph. So a green check means it's passed, and the play button gear is what we saw before. It means that there is an action, a manual action that needs to be triggered before actually continuing. Last but not least, you also see the retry arrows over here as well. So if you only want to retry one single job, you can do this easily by clicking on this button. So this is the very basic example of a .gitlab CI YAML file, which is written in YAML syntax and stored in the root of a project and version control together with the rest of your code. In the CI YAML file, you can define the scripts that you need to run, other configuration files and templates that you want to include, and something that we will see on Thursday as well. The dependencies and caching, the commands that you want to run in sequence versus the commands that you want to run in parallel, the location you want to deploy your application to, and whether you want to run your scripts automatically or trigger them based on any event or manually. So this file has just a couple of those sections to specify jobs and stages in the pipeline. So let's take a look at each and one of them. So the first section here is going to define the stages for the pipeline. Here you can see that they are specified as build and deploy, which means that is also the order that we're going to run the jobs that are part of those stages. So first the build jobs, then the deploy jobs. The second section represents a build job, and you can see that the stage is defined as build, followed by the script for the job and only statement. Now, only we'll cover that in the later section as well, but the only statement are going away, but that comes later on in the section as well. And the last one is the deploy job, and you can see that the stage is specified as deploy, and there are also an environment, variables, and again the only statement included for the job. So here we're going to actually define on which environment and what the URL will be for that environment. This is a static environment example. Of course, dynamic environments are also possible. And as mentioned, there are many other sections and types of content that you can include inside of the YAML file. For this course, we'll be focused on the basic ones for this session. And also, in our session on Thursday, we'll go even deeper on it. So the stages are used to separate the jobs into logical sections. A stage is defined as per job and relies on the different stages that are defined, which are defined globally. You can use a stage to define which stage a job runs in, and jobs of the same stage are executed in parallel. Then you have the jobs and the scripts. So each job needs to have a script statement there as well. And jobs will define with constraints stating under what condition that should be executed. The top level elements with an arbitrary name and must contain at least a script class, and there is no limit on how many can be defined. The script keyword is the only required keyword that the job needs, which is a shell script that is executed by the runner. Next, you can define what image that you want to use. Images can be defined on a runner basis as well, but you can override it on a pipeline basis and even on a job basis as well. So by default, all the images are being pulled by Docker from Docker Hub. However, you can also use the locally stored images in your own GitLab container registry, which is part of your project. We have a couple of examples on how to do this in our documentation, and we'll see that in a moment as well. And so the image keyword can be used as a global scope, which means that it's the default for the entire pipeline run, but also can be overridden in a local scope, so for each of the jobs as well. So if you have one job that doesn't need to run on I don't know, the Node.js or the Ruby image that is in the main pipeline because it needs additional scripts, and you had additional application which are already pre-baked in another image, then you can override that there as well. Sorry. Next, we have services and variables that can be used. The services will allow us to augment our base image with additional functionality. So here, in this case, we're calling our progress layer to add a database service to our base image. Service can be used in both global and local as an image keyword. And on the other side, we have variables. Variables can be global or local again, and allow us to define YAML variables that have an order in the variable hierarchy. For instance, in this case, you have the name of the Postgres database user and password, which might be depending on which environment that you're going to run against, sorry, or deploy into. Yeah. That brings us to environments. So this is an optional part of a job definition, and then an environment. This is an environment called prod in this case. Which creates a section for this in our operation environments tab as well, where you can follow up on the details for it. The when clause defines when this stage is run. In this case, it will be a manual trigger. Other values there can be on success or on failure. For on success, for instance, only if the previous jobs were completely successful, only then we're going to deploy into this or execute this job into this environment. On failure can, for instance, be used for cleaning up an environment. And then last but not least, you also have the always option, where which will execute the job regardless of the status of the job from prior stages. I briefly mentioned that only an accept is not something that you should be using, because these will be deprecated soon. It still works. You can still use them. However, if you're starting something new, you're creating something new, it's highly recommended to use the rules block. And the rules block is more dynamic and more powerful than the only and accept. How the rules block work is essentially you're going to have a statement, so an if statement or the changes statement and the likes, and then define based on the built-in CICD variables that we have in GitLab when it should run. So in this case, as an example, only when it's being triggered from the web form, this job would run. And you'll see it here that we're highlighting it in the rules section, and then we're just saying if this equals true, then we're going to run, and by default it is going to run as well. All right, I'll pause for a moment, see whether there are some specific questions, and if not, I'll move into the project itself. Any open questions that I missed potentially? Don't see any. All right, but then we'll start with some basic pipeline, and I'm going to create one. First of all, I'll start with one of the issues. So if I have already created an issue, because it's not the topic of today, but from here I can create a merge request. So remember the GitLab flow, we're always starting with a problem statement or a body of work where we're going to describe everything. And from there on, we start resolving it. Now we can have multiple merge requests. So for today, I'll create another one here additionally. And for now, we don't have anything defined as a pipeline yet. And that's the reason why we don't see any pipeline section over here. So since we just created a new branch, one of the feature branch, we can click on the checkout branch and do it locally, or we can leverage the web IDE from, to create it from here as well as one of the ways to do it. So you have the IDE locally, which can be done, or here through the web IDE. And because we know what a .gitlab CI file should look like, we automatically provide it as an example, which then triggers our template section as well. Templates is something that we will cover in the more advanced section on how to build it on your own. Today, I'll just start from a CI template called bash, bash example, and I'll just keep it as simple as possible by only keeping the build, test, and deploy stages. As a reminder, by default, build, test, and deploy are always defined, so we don't need to add a staging section over here. So in this case, so we're expecting to have in the build stage one build job, which is going to execute this script. In the following stage, which is the test stage, we're going to have test 1 and test 2 that are going to be executed. And then in the third stage, in the deploy stage, we're going to have one deploy job there as well. Without doing anything further, I'll just commit it, give it a commit message. I don't know, first pipeline. And by default, we're asked to commit to our feature branch. So if I commit it, we'll see that our pipeline gets triggered, which is here at the bottom already. And while we're developing, we can follow our pipeline here as well. Of course, if I click on this pipeline link, you will see the visualization there as well. So what we'll see here is the basic example that we saw in the presentation as well, starting with the build job, then triggering the test 1 and 2 in this phase, but these won't get triggered before the build 1 job is done. So all the stages here, and same goes for the deploy job. Even if only one test has been completed, the deploy job won't get triggered because everything needs to be completed by default. All right, I'll not wait here for it. Another way to build your pipeline is by using the new CICD editor. So if you go to CICD editor, we have a new editor that was embedded, and this is showing empty because I'm currently on the main branch, but we did the changes, not on the main branch, but on the basic pipeline tree branch. This is what we just added to our web IDE. But the advantage of using the editor is that you can immediately visualize it before committing any pipeline, and lint it as well. So there's a built-in linter which will show whether the syntax is correct. This is also part of the web IDE, and you can have it as a plugin for your local IDE, like for Visual Studio or for the JetBrains products, for instance. And once you get started with things like the templating, so that you include definitions from another job by using templates, you will see here the merged YAML file. So essentially how the runners are going to look at the file as well. So in this case, it doesn't really matter because you only have, well, everything is in a single file. But if you have things like includes and the template that are being used, this will give you a full view of everything that was, well, exploded essentially. All right, so we can continue working on this here as well. A couple of things that we will see in a later session are things like the needs, how to speed up everything, how you can do caching, how you can save your artifacts, and what the difference is between artifacts and caching. But I think that's something that we will cover on Thursday as well. Fortunately, we have Vlad, who is available here today as well. So I'm hoping that he will correct me if I'm saying something, if I'm over promising for the session on Thursday as well. So based on this, we have created a simple pipeline already. But you might have seen as part of the templates that are that. Wait, let me go to my merge requests. This one. But you might have seen as part of our templating here that there are way more templates that you can leverage from. And so based on whatever you're doing, whether it's .NET, we have a couple of templates that you can get started with, and essentially gives you a couple of ideas as well. And things that we'll see on Thursday as well, or one of the next sessions, is things like including templates, the rules engine, and the likes, but that will be for our next session. I think we have 10 minutes left now, so perhaps it's a good time to start some Q&A.
I think I answered most of the questions in the Q&A section. We do have one from Mitchell. I was about to write an answer, but I think you can pick it up live, as I think it's an interesting one.
All right, so just found the Q&A section, and thank you for answering that, by the way, Vlad. Mitchell is asking, pipeline can have a lot of jobs which run in parallel and therefore need a lot of runners. If there are also a lot of pipelines running in parallel, you need a huge amount of runners. Is there a good habit as a maximum pipeline execution time? Not sure what you mean with the maximum pipeline execution time, but how we typically handle that is by setting up, well, let me go one step back. So if you install some runners, you need to keep in mind how many parallel jobs that you want to run as well. And depending on the size of your team, there can be a lot of parallel jobs. However, it's not always that useful to have all of that capacity running at all of the time. And that's where auto-scaling runners are coming into play as well. An auto-scaling runner can then ad hoc create a new or an additional runner and add them to your runner pool, run the jobs, and depending on the setting, will tear down that runner again, so you don't overconsume on on resources, essentially. Is that what you were going to say as well, Vlad? Because there's a lot of options.
Yeah, actually, no. Actually, I was about to go down a different route. My answer was mostly in lines of, hey, you can do your pipelines more efficiently by using rules and things like that, not triggering and executing everything every single time. And this is a topic that we'll cover in more detail on Thursday. So for example, here at GitLab, if we do a change to some texts in the handbook or on the web page or in the manual section, the pipeline that will run will be significantly lighter than if we do a change in the web app, for example. That would be my first point. Now, the second point, we do have a pipeline or a job. I don't remember if it's pipeline or if it's job, but we do have a timeout parameter. And if your jobs take longer than 60 minutes, I think it's by default, they will get automatically canceled. So they don't take up time space in your queue indefinitely, pretty much. And you can couple that with what Christoph mentioned, and I think you have the overall approach for this topic. Any additional questions or follow-up questions?
Yeah, also, if you don't feel like typing the entire question, just raise your hand and we'll allow you to talk.
We also had some conversations in the Q&A section around process change management more precisely. We typically don't do strong recommendations around that. We try to be flexible. As I already mentioned, our approach is to go as fast as possible while not taking any unnecessary risks. And with that, having only the approvals in the merge request that you really need. Go with the minimum that you need. Don't expose yourself to any unnecessary risks. Whatever that means depends on a customer by customer basis and context by context. So we cannot offer a wide estimate. Also, the same goes for when to execute linters in the pipeline. By default, we do it, if you're using Auto DevOps, we do it part of the test stage, but the test stage also contains a stub for your unit tests. So we do it pretty much around the same time within the process, even though, of course, depending on how you set up your rules, some jobs might be executed before others, but they are part of the same stage.
Yeah, and to the point of change management, I think the slightly different approach might be that you have to have traceability, essentially. And because everything is being stored in Git and related to each other, because you're working in a single application, it's much easier to do that audit in case that you need it. And if and when that process has been adopted by the audit team, they typically like it because you can have the full traceability of who did what change and whether was there an approval for it, and was that approval compliant as well, because we do have compliancy reports in our ultimate tier as well, which will show that well, Christoph did a change somewhere and it wasn't compliant because he typically is doing a demo and you just skip all the approval flows. Which is possible, but then it gets flagged as a potential compliancy problem, which in a real use case is more interesting than in a demo, of course. But it's very powerful to have everything attached to each other. And to your point of linting, Vlad, I think it also comes back to the point of Mitchell, which is optimization. I believe, and I hit it a couple of times myself, and that's why I'm pretty sure in GitLab itself, we do the linting a lot first, because it might potentially save your on infrastructure cost. Because what you want to avoid is hitting all the tests at the same time, including linting, and then essentially everything works and you have spent a lot of infrastructure costs setting up temporary environments, validating everything, and then there's a linter says no, there's your, I don't know, your indentation is wrong, something like that, because that will be very expensive as well. In that case, it's better to have your linting as fast as possible. I would potentially argue even in your IDE, start there, but that's not a centralized way to do it, of course.
Yes, the session is recorded, and You don't need to integrate with ServiceNow. You do have all the traceability in GitLab, but we can integrate if you want to.
Yeah, ServiceNow has a GitLab spoke as well. All right, any other questions? If not, we can potentially give you a couple of minutes left.
Let me quickly give an overview about the session on Thursday. It's CICD Advanced. We'll do a quick recap of what Christoph showed and talked about today. But then we'll be going into more advanced pipeline architectures like multi-project, parent-child, being able to trigger other pipelines from your project, pretty much. And also we are going to discuss more about includes and templates, as we think this is one of the most important features that we have, and that everyone should use them. And I think there are some other things as well in the session, but that's the gist of it. That's the most important part of the session. Oh, and also controlling your pipelines, using rules and all that stuff to decide when a job should get executed or not, depending on the type of change you make or based on any other criteria that you want. And with that, I think we can close. Thank you everyone for a great session. It was really cool to have this conversation with you, answer all these questions, have that conversation, and hope to see you in the next one. Thank you, Christoph, for a great session today.
Thank you, Vlad. Bye, everybody, and hope to see you all on Thursday.